Hello everyone, welcome back to day 17 lecture of how to learn DevOps and cloud computing in 60 days. As part of today's lecture, we are going to learn about something called infrastructure as a code. So as part of infrastructure as a code, we are going to learn about a tool called Terraform. So let's quickly go through the agenda. So we are going to understand what is infrastructure as a code and what are the key benefits of infrastructure as a code and what are different IAC tools out there in the market. And we will pick up Terraform and then we will learn about Terraform and why Terraform is commonly used across different companies out there. And then what is Terraform architecture and how Terraform really works. And then we will compare Terraform with Ansible and then understand where you can use Terraform and where you can use Ansible. And we will also understand how you can integrate Terraform with AWS Cloud in order to create resources in AWS Cloud. And we will also understand what are some of Terraform commands. And then last but not the least, we will also understand some of the Terraform best practices. Fantastic. So now let's try to understand what do you mean by infrastructure as a code. So there is an answer in those words itself, right? Infrastructure as a code, meaning you're able to create the infrastructure from the code instead of doing it manually. Why we have to go this route? Let's say that you are a DevOps engineer, you are working with a team, you are responsible for creating resources in AWS Cloud. And let's say that there are 4 different environments. So you have Dev, QA, UAT, and production. So now you have to create resources for each and every environment. Now let's say that for each and every environment, you will have to create 30 to 40 resources. So how are you going to create those resources for each and every environment? If you go to AWS console, if you start creating all the resources manually, it is going to take a lot of time for you, right? And you are also doing this manually, you wouldn't be able to scale up. You may make a lot of mistakes as you are configuring these resources manually. That is also not a good practice. So this is where you can actually use infrastructure as a code tool and you can create your entire infrastructure through code and then you can commit the code into any SCM tools and then you will be able to provision the infrastructure in an automated manner by integrating with any CI/CD tool. So basically infrastructure as a code is one of the fundamental building blocks of DevOps. Just like how you have continuous integration, continuous delivery, similarly, infrastructure as a code also one of the fundamental building blocks of DevOps. So what are some of the key benefits of infrastructure as a code? The first thing is speed. And then next thing is consistency. Let's say that you will have to create 4 different environments. All you have to do is write code once and then you will be able to provision as many environments you want by passing some variables. So you're going to write code only once and then you will be able to create as many environments you want. And then this way you can actually maintain consistency across each and every environment. And then you also should be able to version control it so that at any point of time, if you wanted to review or roll back your infrastructure code changes, you should be able to do that. And then scalability. So basically, if you have to create 4 or 5 different environments, you just have to write code once and then you will be able to create as many environments you want. And then you can also provision the infrastructure in an automated manner. So you can scale up and then scale down based on your configuration. And then security and compliance. So this is also very important. You can also enforce policies through code. In this way, your infrastructure is fully of compliance. And then when it comes to cost and optimization, so this is also very important, right? So sometimes you may have a lot of resources, you may not even use it. So you can configure in a way that you can automatically clean up the resources that are not in use. So in this way, you can completely avoid over provisioning of your resources. All right. So yeah, so these are some of the key benefits of infrastructure as a code. So now let's find out what are different infrastructure as a code tools out there in the market. Number one is Terraform, without any doubt. So you go to any company pretty much, right? they would be using Terraform for sure. And then there are other infrastructure as a code tools as well. For example, let's say you're working for AWS cloud. So your client may use CloudFormation, but the limitation of CloudFormation is you can create resources only in AWS cloud. Okay, similarly, let's say that you're working for a client, they are completely into Azure cloud. You can also create resources using Azure Resource Manager. But again, the limitation of ARM is you can create resources only in Azure cloud. So that's the reason why, many companies are preferring Terraform. Why? Because it is completely cloud agnostic IAC tool. And then there are other IAC tools out there in the market as well. So you can also use Ansible, Chef, Puppet, SaltStack, and Pulumi. But scope of this particular, training is the scope of this particular class is, or the scope of this particular lecture is Terraform only. So we are going to discuss about Terraform. So what is Terraform? So Terraform is open source IAC tool provided by a company called HashiCorp. But Terraform also have enterprise edition as well. That is mainly for, licensing, right? But, people like you and me can leverage open source Terraform, and then we should be able to create resources in any cloud. And like I mentioned earlier, Terraform is completely a cloud agnostic tool. So using Terraform, you would be able to create infrastructure pretty much on any cloud platform. And Terraform is completely CLI based as of today. It does not have any built-in graphical user interface. It is purely through CLI. But you can very well integrate with any popular CI/CD tool such as Jenkins or GitHub Actions or Azure DevOps and so on. And then the way Terraform is going to create resources is by creating Terraform files using a language called HashiCorp configuration language, which is completely based on declarative model. So Terraform is really smart enough to understand how to provision the infrastructure. You just need to tell what to do. You don't have to tell how to do. Terraform will actually figure it out based on your configuration files. And then using Terraform, you can orchestrate your infrastructure creation across as many environments that you want. So Terraform is mainly for provisioning and orchestrating. So Terraform does not have configuration management capability by itself. So we will discuss that in our upcoming slides. So why you have to go for Terraform? So as we discussed, Terraform is a cloud agnostic tool. Using Terraform, you would be able to provision as many cloud platform. For example, let's say you're working for a customer, they are using multi-cloud. So they are creating, some resources in AWS cloud. They're also using some resources in Azure cloud or GCP. The best option for you is to use Terraform. And then like we discussed, whenever you're using Terraform, you would be able to, create any environment that is completely consistent. Okay, and then you would be able to scale up the infrastructure as well, right? And then Terraform also has obviously version control, meaning you can create Terraform files and then you can store your Terraform files in your SCM tool. And then Terraform also has this amazing feature called modules. So whenever you want to create as many resources you want, you can actually start leveraging Terraform modules. So in this way, you're not actually reinventing the wheel. So you're going to write code only once, and then you would be able to create as many resources you want. And then Terraform has this amazing, feature of automated provisioning by integrating with any popular CI/CD tool. So in this way, you are completely avoiding manual way of creating resources using Terraform. Okay, so now let's try to understand the Terraform architecture. It is actually pretty straightforward. Let's say that you are a DevOps engineer, you would be creating Terraform configuration files using a language called HCL, which is nothing but HashiCorp configuration language. And then once you create your Terraform files, obviously you're going to commit that into version control. And then you have your Terraform core. And using that Terraform core, you would be integrating with any cloud platform by using something called provider. For example, if you wanted to integrate with AWS cloud, you're going to use AWS provider. Using that provider, you're going to make an API call into AWS cloud. Okay, and then the way Terraform is going to manage all the infrastructure changes is by creating a file called terraform.tf state file. So that is actually a crux of your Terraform. And we will discuss, whenever we are performing any lab exercise, so we will understand more about Terraform state file. But for now, Terraform state file is a single source of truth. And the way Terraform is going to manage the infrastructure changes is by keep updating the Terraform state file. So now let's try to understand how Terraform really works. So you can categorize them into 3 different stages. So the first stage is write. So that is where you're going to define your infrastructure changes in Terraform configuration file. So you would be using HCL language in order to create your infrastructure changes. And then you also have your Terraform state file. So that is where Terraform would, update all the infrastructure changes. And then that is where it would also read the current state of your infrastructure by reading the Terraform state file. And then whenever you execute, it would compare the current state with the target state. And then it would actually create the infrastructure. And then you have something called plan stage. So once you have created your Terraform files, you must execute Terraform plan command. So what this will actually do is, this will review your changes and then it will clearly tell you how many resources will be created, how many resources will be modified or deleted, right? So Terraform plan will not actually build the infrastructure. It is just kind of a read only, right? It will clearly show you what it is actually going to do. And then the apply stage, right? So that is where you can start building your infrastructure changes. So once you're okay with the plan, then you can go ahead and then execute Terraform apply command, which will actually build the infrastructure changes. Either it could be addition of new resources or modification of your current resources or deletion of your resources as well, right? And whenever you are performing apply, you also need to give some kind of an approval during Terraform apply command. So we will understand during the demo part of it. So now let's try to understand the difference between Terraform and Ansible. So like I mentioned earlier, Terraform is mainly for provisioning. Terraform does not have any configuration management capability by design. If you wanted to achieve configuration management capability, you will have to integrate with any configuration management tool such as Ansible or Chef or Puppet. But in our case, let's just talk about Ansible, right? So using Ansible, you can manage configuration changes. So if you look at this diagram, so Terraform is mainly for provisioning, right? So it can create any resources that you want in AWS cloud. But if you wanted to make any configuration changes, you will have to go with any kind of a configuration management tool such as Ansible. So using your configuration management tool, you can configure your VM or anything, any configuration changes, you should be able to achieve that. Okay. So that's the reason why, I have seen companies use Terraform for provisioning the infrastructure, and then they would leverage Ansible for configuration management capability. Okay. So now let's try to understand how you can integrate Terraform with AWS cloud. So the way Terraform is going to integrate with AWS cloud is by using AWS provider. So how do you think you can have AWS provider? You must execute Terraform init command, which will actually download the AWS provider. Similarly, let's say you want to integrate with Azure cloud, you also need to download the respective provider like Azure provider, right? But we are talking about AWS cloud only, at least for this particular lecture. We will also learn how you can integrate Terraform with Azure cloud, maybe in some other lecture. But whenever you wanted to integrate Terraform with AWS cloud, so you need to authenticate with the AWS cloud, right? So you can actually do it in 2 different ways. Let's say that you have set up Terraform on your local machine, let's say you're using Windows machine or MacBook, you must download access keys and secret keys. Okay, so using that access key and secret key, you would be able to authenticate with AWS Cloud. And then you would be able to access AWS Cloud by using AWS provider. Or let's say that you have configured Terraform on your EC2 instance, which is already running in AWS Cloud. All you have to do is, create an IAM role and then attach necessary policies to your IAM role, and then attach your IAM role to the EC2 instance where you have installed Terraform, and then you would be able to provision the necessary resources in AWS Cloud. It is as simple as that. So we will definitely understand during the demo part of it. Okay. So now let's try to understand most commonly used Terraform commands. So this is pretty straightforward. It is not very difficult to understand. So first thing first, right? You'll have to execute Terraform init command that is mainly for downloading provider plugins. And then it will also initialize your Terraform working directory. So without executing Terraform init command, you wouldn't be able to integrate with any cloud platform. Okay, so you have to execute Terraform init command in order to download the respective provider. And then let's say you are completely new to Terraform, you're not sure about your Terraform code. So you have started writing your Terraform code, right? And then next command is Terraform validate command. So let's say that you are completely new to Terraform or completely new to programming or scripting. So you're not too sure about your Terraform, file code changes. So you can actually execute Terraform validate command in order to check for any syntax error in your Terraform configuration file. It's very useful command actually. And then Terraform plan command, like we discussed. Once you have created Terraform files, you wanted to understand how many resources would be created or updated or deleted. You can actually execute Terraform plan command. And then Terraform apply command is mainly for building your infrastructure changes, right? So you are going to execute Terraform apply command. And then Terraform destroy command, this is mainly for destroying all the resources that you have already created, or if you want to destroy a specific resource, you can also use Terraform destroy command as well. But you have to be extremely careful when you perform Terraform destroy command, because you're going to lose all your infrastructure changes. If you're not careful, so you may lose all your infrastructure changes with Terraform destroy command. Okay. So yeah, so these are all, most used Terraform commands. So now let's try to understand the Terraform best practices. So the first thing is you have to use remote backend for storing your state information. Now let's say that you have installed Terraform on your local machine. So you are executing, Terraform plan or Terraform apply command. So by default, Terraform would create Terraform state file on your local machine, and it will always sync up in your local machine, right? So that is nothing but local state file. But the good practice is when it comes to team environment, you must store your state file remotely, which should be accessed by all the team members. So for example, let's say you are working on AWS Cloud. So you are part of a DevOps team. So you must store your Terraform state file in AWS S3 bucket so that, all your team members can access your state file. So you must use remote backend, not the local state file. And then you must organize your Terraform code using modules. So that is the beauty of reusability, right? So you don't have to reinvent the wheel. So it is advisable to use Terraform modules for provisioning your infrastructure changes. And then you must use version control, obviously, right? So once you start writing your Terraform files, you must commit them into any SCM tool that your company is using. And then it is also advisable to use variables and outputs. So you don't want to hard code any values in your main.tf. Rather, you should, declare everything in variable file. And similarly, it is also a good idea to write into output, the console output, so that you can pick up the IP address or anything like that, right? URLs you can actually read from your output file. Okay. And then it is also advisable to enable state locking. For example, let's say you are using S3 bucket to store your Terraform state information. And when any of the team members trying to access Terraform state file, so you need to have exclusive lock capability in order to prevent conflicts. So we will definitely address that during our demo part of it. Okay. So yeah, so these are all, some of Terraform best practices. All right. I hope this lecture was really useful. I'm really looking forward to see you all in the next upcoming lecture, where we are going to start Terraform lab exercises. Thank you so much, guys.